Hello, my name is Shawn Hawkins. I'm an associate professor in the Biosystems Engineering and Soil Science Department at the University of Tennessee Institute for Agriculture. I'm going to be speaking with you today about producing corn using poultry manure as a fertilizer. I'm going to go ahead and, and pull up the presentation, and also I'm going to be removing my video feed so that you have the full benefit of the entire screen for graphs and tables I'm going to present. The title for today's talk is Effective Use of Poultry Manure in Corn Production. This is part of the proceedings for the 2020 Milan No-Till Virtual Field Day. So the goals for today are, number one, I'd like for our corn producers to learn a little bit more about the poultry industry, specifically in Tennessee. So I'll begin with the poultry production primer. We'll talk about the origins of broiler litter and what I refer to as breeder manure. We'll focus on broiler litter characteristics. We'll also discuss why broiler litter, in my opinion, is a good corn fertilizer, and particularly a good starter corn fertilizer. We'll do that in discussing nitrogen fertilization rates and mineral fertilization rates, and interspersed throughout these three topics, I'm going to be presenting some ongoing applied research that began last year at the Milan Research and Education Center, where we're producing corn grain using litter as a fertilizer and comparing yields and characteristics of the crop between manure, litter, and broiler litter and commercial fertilizers. So let's take a few minutes to speak to talk about the types of poultry farms in Tennessee. We have two types of farms, breeder farms and broiler farms. One thing that we do not have in Tennessee are layer farms. Layer farms are commercial farms that are used to produce table eggs. Those are produced in the Midwest on commercial farms and in states like Pennsylvania. We do have breeder farms, though. These are farms where male and female chickens are brought together to produce fertilized eggs to feed into the broiler industry. A broiler is a meat chicken. We have several different types of breeder farms. The first is a pedigree farm. Those are commercially owned by the companies that own the genetic lines for the birds. This would be companies like Covantris and Aviagen and also Hubbard. They contract with private farms to breed the great-grandparent and grandparent broiler stock. And then the eggs from the grandparent stock are sold to broiler integrators. These are companies like Tyson Foods, Cook Foods, Pilgrim's Pride, Purdue, the companies that sell poultry meat. Those parent stock are raised by private farms under a contract with these integrated companies. The vast majority of the birds that are actually present and growing in Tennessee are in fact the broilers. If you can imagine that this group of farms is kind of like an inverted pyramid. At the very peak, there are very few of the pedigree farms, and at the base there are the vast majority of the farms are broiler farms where private individuals are growing meat chickens in successive flocks out. They're growing these birds out for broiler integrators. And that's the vast majority of the source of poultry manure in our state is the broiler farms and not the breeder farms. To give you some idea of what these farms look like and where the waste comes from, this is a photograph of a breeder farm. This is a nest box row here where the hens are laying eggs. There's a conveyor under it that carries the eggs to a holding room. Those will be taken to a hatchery to be hatched. The important thing for us to, in terms of the waste, is that the nest box is raised on slats, and the manure from the majority of these birds falls through these slats and accumulates under the slats without any bedding. So this would be called breeder manure, and we're calling it manure because there's very little bedding added to it. There is a central scratch area here that's composed of bedding, but the majority of the characteristics of the waste are associated with the manure that accumulates underneath the slats, and that is that the moisture content is fairly high, the nutrient content is high, but because the moisture content is high, it's difficult to stack this waste. This is a broiler farm, and broilers or meat chickens are raised on a dirt floor that's been lined with bedding material. The mixture of the bedding material and accumulated waste from the birds is referred to as litter. And this is the majority of the waste that's produced in the state simply because the vast majority of the poultry houses in the state are broiler farms, those farms that are producing meat chickens under contract. So let's talk for a few minutes about the characteristics of broiler litter. It typically tests as approximately a 3-3-3 fertilizer, meaning there's 60 pounds of nitrogen, P2O5, and K2O in each ton as is of broiler litter. That being said, you should get an analysis if you're purchasing broiler litter to use it as a crop nutrient source, because litter management varies from farm to farm, particularly in how the litter is managed between flocks, and that does affect the nutrient content of the broiler litter. A critical factor in using broiler litter as a row crop nutrient source is realizing that not all of the nitrogen in this material is 100% available to produce your crop. Um, the nitrogen is largely in an organic form and a slow release form. So once the material is applied to the land surface, the organic matter has to be broken down by bacteria in the soil to release that nitrogen and make it plant available. And in any given year, only about 45% of the nitrogen that's applied is going to be available to produce the crop for which it's applied. And that's going to vary. There is some risk in this variability. It varies anywhere from, let's say, 25 or 30% up to some years could be 75 or 80% availability. This is a map of where these farms are located at in Tennessee. I'm not going to go over this in great detail. You'll have access to this overhead, and you can look at it and see where these farms are located, focusing on the broiler companies again. The area I am going to focus on is an 8-county area or so where the 2 Tyson facilities are located in Northwest Tennessee. The vast majority of the broiler producers that produce birds that are going to feed into these processing plants, the first being in Union City in Obion County, and the second being under construction in Humboldt, Tennessee, and Gibson County. The vast majority of these growers are going to be in Lake, Obion, Weakley, Carroll, Madison, Gibson, Crockett, Haywood, and Dyer County. This represents approximately 75% or so of the corn that's produced in the state. So poultry litter and poultry manure and broiler litter are important sources potentially for using for use as a nutrient source to produce corn in these very important corn producing areas. So what I've done here is this is a presentation for Northwest Tennessee for those counties that I just discussed. The crop removal for the 4 major row crops of phosphorus as P2O5 and potash K2O for corn, soybeans, wheat, and cotton. Basically, I took the yields for those 4 crops and I've multiplied them by an estimate of the P and the K content. And based on the county yields, we can see that somewhere around 70 million pounds of P2O5 is removed from these soils every year in these major row crops, and 80 million pounds is removed as K2O or potash. So we can remember, we know that the litter is approximately a 3-3-3 fertilizer, so we can estimate based on the number of birds that we're processing at these plants in Humboldt and Union City, how much phosphorus and potassium is going to be present in the broiler litter. And it represents, in fact, a significant source of these nutrients in these counties, these important corn producing counties. About 15% of what's being removed in corns, soybeans, wheat, and cotton in these counties. And it represents a significant contribution to the local farm economies there. Our take-home messages for the first part of our presentation: most poultry manure is broiler litter. About 90% of what's going to be available to use as a nutrient source to produce corn is going to be broiler litter. It tests at about a 3-3-3 fertilizer. About 45% of the nitrogen is available. Most, if not all, of the P and K is available. It is dry and stackable because it includes bedding, and it's very important nutrient source potentially in Northwest Tennessee because of the processing plants that are under construction and that are already built there. Breeder manure is only about 10% of the waste. It's much less common, obviously. It has a higher nutrient content, but also a higher moisture content, and it makes it less stackable. So there's slump involved with that waste. And so most producers that are using corn or they're producing corn and using poultry waste are in fact using broiler litter. So now I want to go into why I believe litter is a good fertilizer for corn production, and in particular, a good starter fertilizer. We'll begin by examining the nitrogen recommendations for corn production published by the University of Tennessee Extension. And you can see that unlike for most other crops, we have tiered nitrogen application rates that vary depending on the yield potential for the field in which the corn is growing. Our recommendations vary from 120 up to 240 pounds of nitrogen per acre. And the important thing to realize here, and one of the key factors in why litter is such a good fertilizer for corn production, is that any application rate of nitrogen over 120 pounds of nitrogen, we recommend that you split that nitrogen application, put 1/3 of it down at planting and 2/3 at the V6 growth stage. And that brings us to really an important point of why litter is such a good fertilizer for corn production, and that is that there's low risk for the variable nitrogen supply from litter if we apply the litter at planting. And this is because there's low demand for nitrogen from corn up to the V4 to V6 growth stage. That translates into low nitrogen availability risk. The other 2/3 that gets put on at planting, that's when the demand for nitrogen greatly increases from V6 through tasseling and the reproductive stages. There's high nitrogen availability risk there. And in that case, organic fertilizers could be used, but they're difficult to apply, frankly. We don't have good equipment that can be used to apply organic fertilizers and protect the corn that's emerged. The second reason that corn is a good crop to fertilize with poultry litter is because the University of Tennessee Extension publishes a pre-side dress nitrate test and is calibrated for corn. This is an example of an interpretation of that from this past year's corn production at the Milan Research and Education Center. Here we have our positive control. This is the nitrate concentration in the soil there. This is a 12-inch soil sample. So these can be pulled and subject to a nitrate analysis. The positive control of commercial nitrogen, and then we have varying rates of litter. And you can see that we had slow release of the litter this past year. And the beauty of this pre-side dress nitrate test is that you can make recommendations then, receive recommendations on the additional nitrogen that would be required, for example, for a corn crop that's going to be producing in excess of 175 bushels per acre. Obviously, the thing that really stands out here is that we had a good accounting of the commercial fertilizer that was applied. Litter simply can't provide all of the nitrogen for a high-yielding corn crop. This is data from the corn ear leaves that were collected from our research this past year. The ear leaves were collected at the silking growth stage R1 to R2, and you can see that the litter, that the leaf nitrogen content varies depending on and reflects whether or not there's been a low provision of nitrogen, a deficient provision of nitrogen, and a sufficient provision of nitrogen from the fertilization efforts. The positive control obviously was sufficient. The litter is increasing. The nitrogen content of the ear leaves does increase, but it's all remaining in the deficient range. So in this year, when we had very high yields, we experienced deficiencies when we used litter as a fertilizer, even at high rates. This is the yields for this past year's results. You can see that we broke a record actually at the Milan Research and Education Center, averaging almost 250 bushels of corn an acre. That's non-irrigated. We did have very good yields for our high rates of litter, but not nearly as high as we did with our commercial fertilizer. So I think that some combination, obviously, of commercial fertilizer at V6 and litter at planting is probably best. You can clearly see that the litter does induce a yield increase as the litter application rate increases. The third reason that I believe corn is a good recipient for litter, broiler litter as a fertilizer, is because the mineral nutrient requirements for corn are very high. Here I'm showing the application rate recommendations for P2O5. This is for grain and silage. We're going to focus on grain here. You can see that it varies depending on the yield potential for the field and whether or not your soil is testing in the low or medium level. Soils that are high yield potential and lower in soil phosphorus test levels demand very large rates of both P2O5 and K2O. And for that reason, because litter contains high concentrations of these nutrients, it makes it an excellent fertilizer for this crop. Even if you have soils that are testing, let's say in the high range for phosphorus or potassium, where those nutrients are not limiting yield, you have to realize that grain mineral removal rates of phosphorus and potassium are still quite high, and if we apply litter, we can replace that phosphorus and potassium using litter nutrients, perhaps at less expense than commercial fertilizers, and that these removal rates are quite large. Last year with our high yields at Milan, between 100 and 150 pounds of P2O5 per acre for P2O5 and between 75 and 100 pounds an acre for potash. These are the results for the soil test that we collected about 2 months ago. This is from all of the plots that received varying rates of litter application, 2, 3, 4, and 7 tons an acre. And you can see that our Malic 1 extractions of phosphorus, this is an extraction that mimics what the plant has available, is obviously increasing as the litter application rate increases. This should give you some confidence and demonstrate that, in fact, the phosphorus that's being provided in the litter is crop available. I have similar results for potassium, but we're not going to show those in the interest of time. The final reason is that litter provides secondary mineral nutrients, and all while providing nitrogen, phosphorus, and potassium. The critical nutrients for corn are sulfur, boron, zinc, and potentially copper. I have a result here for zinc that shows that the concentrations do clearly increase even after just 1 year of litter applications between 2 and 7 tons an acre. Our take-home messages: litter is a good starter fertilizer for corn. The reason is we split our nitrogen application for corn. That lowers the risk of the variable N that's going to be supplied by litter. We have a backup. We can use the pre-sidedress nitrate test to fine-tune our commercial nitrogen rate at V6 if you so choose to use that. I'm often asked what I think an ideal application rate is for corn. I believe that 3 tons an acre is a good rate that provides about 80 pounds of nitrogen and 180 pounds each of P2O5 and K2O. That's plenty of starter nitrogen even for high-yielding fields, and enough P and K to last 1 to 2 crop production years for continuous corn or corn in rotation with soybeans. Please remember not to over-apply litter and build soil phosphorus concentrations to excessive levels. That is a water quality concern, an environmental concern. And lastly, litter does provide a broad array of mineral micronutrients, and we've shown that those are plant available. And we've shown with the results that I've shown you today that we do get accumulation of these mineral nutrients in soil. Be aware that we have a publication, W796, which is a litter land application worksheet. It will help you compute your fertilization rates based on the nutrient analysis that you have for your litter. Make sure you get agronomic utilization of all of the mineral nutrients and nitrogen in litter. Thank you. I'd like to acknowledge this research was made possible with a grant from Tyson Foods. Thank you. Please, if you have any questions, don't hesitate to ask. You can send me an email. Here's my email address. Or if you prefer, I don't mind if you call. This is my cell phone number. Please call with any questions that you may have. Thank you. I appreciate your attention today.